as an orientation to where we are and what this lesson is. This one is for Algebra 1. It's semester 2. It's the first unit, which is exponents. It's the fifth lesson inside of exponents called Powers, Radicals, Fractional Powers Practice. That's the name of it. When you pull up this video, you're going to look for this title. And it is all on the table of contents on Creator Math. So I'm going to go ahead and start here and say, given the square root of x, what is the power of the x on the x, right? So first remember what a square root of x is. Here's an x, right? And here's a square root symbol. The square root symbol literally has 1, 2, 3, 4 lines. On the computer, it looks pretty minimal. They have like this thing, they go like this. They don't even have the bar that comes over and across. So on the computer, it might be like that. But for me, I'm going to draw it the old-fashioned way. I'm going to do a square root symbol. The thing is, on a square root symbol, there's a power of the root, and there's a power on the item under the square root. The root in this case is 2 because nothing's listed here. If nothing's listed, it's a 2. There's a power on the x, and it's 1. And remember the 3 invisible 1 rule. If you have an x, there's 3 invisible 1s. There's a power 1, there's a multiply 1, and a divide by 1. Now, we don't show the 3 invisible 1s. That's why they're called invisible. We just show an x. And same thing if you had a 5 or whatever number. There's a 1, a 1, and a 1. There's 3 invisible 1s on all numbers and variables in math. We just write this as a 5, you guys. We don't write all those invisible 1s. So we don't show a 1 here because it's invisible. And we don't show a 2 here because every square root is to the root 2 if it's not shown. All right, so they want to know, given the square root of x, that's what we have, what is the power on the x? The power is 1. That's all they want to know. Kind of crazy for students. They're like, what is this question even asking? Let's do the next one. It says, given the square root of x, what is the root value? So same thing. Here's x, here's the square root of x. There's a power 1 and a root value of 2. Neither are shown. Nobody's going to show a 1 and a 2 here. They're just going to write radical x. Radical means square root means 2, power 2, or root 2, right? Squared if it's squared, or root 2, or square root, it's a power 2. So 2 here. So what's the root value? 2. Right? So this is sort of a very strange lesson because it's talking about fractional powers, and I'm going to show you more in a second. Let's keep going. Given the cubed root of x, what is the power on the x? So it's already drawn here. Let's redraw it. Here's the x, and here's a cubed root. Now you can't leave this blank now because everyone's going to think it's a 2 root. You've got to label it a 3. So this is a 3 root on top of an x. What's the power on the x? It's 1. It's not shown. And what do they ask us? What is the power on the x? 1. Sort of a very strange lesson where draw out what they're telling you and then go ahead and answer the question. Given the cubed root of x, so let's write x cubed root. That's what the cubed root of x is. What is the root value? The root value is 3. Very strange, but it's trying to focus students on this idea of where the power and root symbols are and what the value of those is. Given the 4th root of x, what's the power on the x? Well, some students don't even know this, but this root number can keep going up to infinity. So here's an x, and here's a 4th root. The 4 goes outside the root symbol. You can go 5th root, 6th root, 7th root, 8th root, 9th root, right? What's the power on the x? 1. What's the power on the x? 1. We don't show it. Piece of cake. As long as you know what they're doing, it's a piece of cake. If not, I'm telling you, this can really stump students. Given the 4th root of x, what's the root value? Here's the 4th root of x. The root value is 4. So power on the x is one thing. Root value is the other, right? So 4. All right, let me keep going. And you're going to see where we're headed. We're headed in a direction with this, and we'll get there in a minute. Given the cubed root of x squared, what's the power on the x? So now I have an x squared, which is an x to the power 2, and I have a cubed root. A cubed root is a root symbol with a 3 outside. So the root value is 3. The power on the x is 2. And sometimes students find this easier to understand than what is the square root of x, because we don't show these. Now all of a sudden we do show the power, we do show the root value. So this one's asking what's the power in the x? 2. Given the fourth root of x cubed, fourth root, what is the power on the x? 3. All right, very interesting. Very difficult if you don't know what they're asking. Very easy if you do. Given the cubed root of x, so let's draw it out. The cubed root of x squared, x squared cubed root. What is the value of the root? What is the root value? So the root value is 3 out here. This is the power. This is the root value, 3. Okay, and we know that. Now, cubed is because it's 3-dimensional. Squared is because it's 2-dimensional. We'll get back to that in a bit here. Given the fourth root of x cubed, let's draw it out. X cubed, fourth root. What is the root value? 4. They told us, we drew it, we answered. Basically testing us on the position of power and root and the vocabulary used to describe those positions, right? Given the square root of x, what is the fractional power? All right, this is going to blow most students away the first time they see it. Given a square root of x, let's label the power as a 1, it's hidden. Let's label the root value, it's a 2, it's also hidden. We don't show it because if they're not shown, those are the default values. Now, let's take this out from under the root symbol. Here's what happens. This equals x, and we get a fractional power. The 1 goes on top, there's a fraction bar, and the 2 goes underneath. And we can say this is x to the power 1/2, or 1/2 power. And what it really means, it's the square root of x. So students will then learn later, oh, this is equal to the square root of x, and they kind of don't get it. This explains it. The 1 goes to the top, the power goes to the top, and the root goes to the bottom. And you get a fractional power, a power that's a fraction. So we're going to mark, what's the fractional power? 1/2. All right. But wait, there's more. Just like a Ginsu knife. All right, given the cubed root of x, what's the fractional power? So let's draw x and the cubed root of it. What's the power on the x? 1. The format is the 1 goes on top, it's your numerator, and the 3 goes into the denominator position, The 1 goes to the numerator, and the 3 goes to the denominator position, and this becomes a fractional power, so the whole fraction is up in the superscript position, the power position, so x to the 1/3. So 1/3 is the fractional power. Given the fourth root of x, what's the fractional power? This is a fourth root of x. There's a hidden 1 here, an invisible 1. The 1 goes up top, the 4 goes under it, and the x is here. It's x to the 1/4 power, 1/4. Given the cubed root of x squared, what's the fractional power? Cubed root, here's a cubed root of x squared. This equals the x, which is the base. Now for the power, it's fraction. The 2 goes in the numerator. The 3 goes in the denominator. This is x to the 2/3 power. So they ask, what is the fractional power? 2/3. Given the fourth root of x cubed, what is the fractional power? All right, so we've got a fourth root of x cubed. The 3 goes on top of the fraction, the numerator. The 4th is the denominator, and the x remains the base. This is x to the 3/4 power. So what is the fractional power? 3/4. Given x to the 1/2, what is the root value? Now we're going to reverse it. So let's first write x to the 1/2. Now, we know that we can write this in a root setup where, here's a root. There's an x under it. This top one goes on the power. So just reverse what we did before. The power was the numerator, so now the numerator is the power. And the denominator was the root value, so the 2 comes here. So this is, and we don't show it when it's 1 and 2, those are the default. This is the square root of x. So this is a square root of x. So they say, what's the root value? Square root, or 2. Okay, given x to the 1/3, what's the root value? So let's take x to the 1/3. Let's now convert that to an x to the power 1 here and a third here. What's the root value? 3. So cubed, because it's 3. And why do we use cubed? Because it's 3 dimension. Why do we use squared for 2? Because it's 2 dimensions. Given x to the 1/4 power, what's the root value? Let's draw it out again. X to the 1/4. Let's put a root in here. The x goes here. The power on the x is 1, because that's its position. The fourth is the root. It goes out here. So what's the root value? 4, or fourth root. Given x to the 2/3, what's the root value? X to the 2/3, which is a fractional power. We have it under a radical. What's the power on the x? 2. Because the numerator is the power, the denominator is the root value, right? So the 3 comes here. So they say, what is the root value? 3, or cubed root. Given x to the 3/4, x to the 3/4 power, all right? Let's map this out. The x power is 3, because that's the numerator. The root value is 4. They ask for what is the root value? 4th root. All right, let's transition to a couple more ideas. If we have a negative value and we raise it to a positive or an even value, not positive but even, a 2 is an even number, we are going to get a positive 9. Why? Because a negative 3 times a negative 3 is positive, right? So positive 9. Now what they're doing is saying, if we have the same negative number, it's negative, and we're raising it to an even value, even over here, this thing's going to be positive no matter what. So even though it's 400, the power 402, which none of us are going to write out 402 times. We don't need to. The pattern is even powers take a negative base and make it positive. All right, it's a little complicated. Look at the notes to see what's happening. Make sure you're writing the notes in your comp book too from creatormath.com. Here it is again, now with an odd number, so we used 3. Well, negative x times negative x times negative x, I can do 3 of them to the power 3, right? Negative times negative is positive. Positive times negative is negative. This answer is going to be negative, and in this case, it's negative x cubed. Now what they're doing is going up to an absurdly large odd number, 101. And they're saying, what happens if we have this negative x raised to this absurdly large odd number, 101? Well, it's going to be negative. So that's what they're going with that. You don't have to calculate it out. I don't have to write 101 negative x's to know it's going to be negative. I know the pattern already. All right, last thing. I want you to try your calculator on this, and maybe I will too. Let's see if my calculator's running. If we go ahead and say 2 things. Negative 3 in a parentheses to the power 2 equals negative 3 times negative 3. However, if you don't have a parentheses, the power 2 is only on the 3. So you have 3 times 3, which is 9. And then you have this negative on the outside, which becomes negative. This equals positive 9. This equals negative 9. And there's a question in there that says, this versus this, I think. I didn't write it out on this one. You're going to have to wing this one. And it says plus 9 versus minus 9. And I urge you to use your calculator for order of operations issues like this, because your calculator's programmed right. Let's see if I can show you this. Here's my phone. Most of you have a calculator. Go ahead and open that up. Let's clear this, and let's do 2 things. Oh, you're going to need to rotate your calculator. There we go. When it rotates, you have a whole new calculator. And what I want to do is do a power here. So let's see, I've got the power 2. Can I see both at the same time? There we go. So I've got negative 3 in parentheses to the power 2. So let's try that. Let's try here, x squared. No, nothing happens. Let me try it again. 3 negative parentheses x squared. There we go. So this is like the first one, negative 3 caret 2. Notice they even use a caret in theirs, right? That means raised to the power 2. Negative 3 to the power 2 is 9. Check, and notice it's positive. Let's take out the parentheses. There we go. There we go. Notice the answer has changed to negative because now this negative is not included in the power 2. The power 2 raises the number, the base it's attached to. If there's no parentheses, this negative is outside what's being squared. So I want you to try it on your calculator, but it's a very interesting order of operations idea. I think I remember when I was a student in high school, my algebra teacher told me this, and I was like, nah, it doesn't work that way. This is going to square it, and you're going to get a positive 9. Nope. There's a proof right there. Negative 9. Okay, so you're going to creatormath.com. You're making sure you got the notes in your comp book on the right page, and you're making sure to do this assignment using this video in the Schoology. Okay?